This video is brought to you by our amazing supporters over at Patreon. Hey everyone, it's Ben from Board to Bits, and welcome to the first installment of my series about non-game game dev. All the stuff that goes into your game that isn't the game itself. So in this first video, we are going to set up a very simple game, but that's really just kind of the vehicle for all the other features that we're going to look at in future videos. So I'm really going to kind of gloss over the mechanics of the game and stuff like that. That's not what this is about, but I will get into a little bit more detail at the end of the video about the way I'm setting it up so that you can easily communicate into and out of your game, which other things like menus and level loading systems and things like that are going to need. So with that said, we can get started. One quick note, I am using new Unity 2017.1 for this. I want to make this series kind of as evergreen as possible, or last as long as possible. So I am using the latest final update here. So if you are using an older version, it should still work for you. I'm not doing anything that's going to be super involved with those features, but bear in mind that there might be a few things that look a little bit different. So first thing I'm going to do, I'm going to start a new project here. And I'm naming it non-game dev, and we're going to do a 3D project, and we're just going to create that. Now we're going to need a few objects in our scene. First thing I'm going to do is I'm going to create a 3D plane, and then to that I'm going to child two empty game objects, as well as a capsule and a cylinder. I'm also going to create a cube as well that's not parented to this plane. Do some quick renaming here. The plane is actually going to be our level. The first game object is going to be the boundaries of our level. Next game object is going to be an obstacle folder. The capsule is our player, and the cylinder is our goal. The cube will be an obstacle prefab we're actually going to make. So I'm going to be getting rid of this later, but these are ultimately going to populate into the obstacle folder, and we're going to do that procedurally. So the level is pretty much in good shape, but we do want to add some materials here. So I'm going to start off by creating a folder called materials. Open that up, and we're going to create a new material, and this first one I'm going to call ground. I'm going to drop down the smoothness because that's just kind of the aesthetic I like. Feel free to make your materials whatever you'd like them to be. I'm going to make this kind of a green grassy color. I'll give it a little bit more blue. I'm going to apply that to the ground there, and then I'm going to duplicate this. I'm just going to do Control D to duplicate it. You can also copy paste whatever you like, but we're going to make 4 total materials. This next one I'm going to call obstacle, call one player, and the last one will be goal. And we're just going to choose some colors for these. I'll make the obstacles gray, kind of a dark gray. Player, make kind of purple, stand out against that green, and the goal we'll make a nice blue, kind of calming blue color. Go as Bob Ross as you like on these. So the obstacle, I am going to apply to the obstacle there. The cylinder, we will apply the goal color, and I can just barely see the player there. So I'm actually just going to drag this onto the player here, and you'll see that that will apply there. Now these are all obviously on top of each other, and that's okay, because like I said, we're going to be positioning things through the level manager script that we're going to create. So we can actually leave these here. However, I do want to make sure they're all kind of properly standing on ground level. The obstacle, we just need to move up to Y 0.5 for that. The player, I'm actually going to size down a little bit. We're going to make it a scale of about 0.75, I think. And then for Y, for that, we can just put it at, I believe we just need to put that at 0.75 as well, yeah. And so that'll be, if we go to like the X view here, we see that that's right on that plane. And then finally, the cylinder, the goal, I'm actually going to keep the scale for X and Z, but for Y I'm going to make it about 0.2 high instead. and then just put it at the 0.1 height so that it as well is sitting on top of the ground. For the boundaries object, the purpose of this is going to be is to keep us from being able to just fall right off of the level. It's not hugely necessary for what we're doing, but I like it just in case we're trying to show something later on, like any features that might involve this. So what I'm going to do is I'm going to add a box collider. I'm actually going to add 4 total box colliders onto this object here. And the first one I'm going to make, and we're going to position this one. I'm actually going to go to the Y view so that we can see where these are being positioned. So the first one, the center we want at X of 0, and we'll put the Z at about 5.5, and then the X width will be 10. This next one here, same thing, but down at the bottom, so we'll say negative 5.5, width of 10, and then these two are going to be the same idea, but just the opposite sides. So this one we'll put at negative 5.5 and make the Y 10. Oops, not the Y, sorry. The Z 10. And then finally this one, 5.5 and Z 10. There we go. So now this is just going to be able to prevent us from flying off of the stage by accident. The obstacle folder, we really don't need to do anything to. All this is just going to be an empty game object that's really just a transform parent to these obstacle prefabs that, like I say, we're going to populate. The player object, we're going to add the component character controller. Usually I would kind of spin my own, but for the purposes of this series, it'll do the job. And for the goal, we're actually going to get rid of, cylinders come with a capsule collider on them, and I'm actually going to get rid of that and instead just use a sphere collider, because that's really all we need for this. And I'm going to, let's focus in a little bit on that, because what's a little bit weird, let me get rid of this mesh renderer for a second so that we can see here, that the size of the collider is much bigger than the sphere, or is much bigger than the cylinder right now. So I'm just going to knock that down to about a half radius. And so what this is going to do, and we're also going to make this a trigger, because basically I want to be able to walk kind of through this cylinder as if it weren't really there, but I do still want it to trigger when you hit the goal that we're going to announce, oh, the goal's been reached. So with all of that done, we're actually in good shape here. I am going to go into our assets. We're going to create a prefab folder. Oops, not a prefab. Delete that. Create folder and just call this prefabs. And we're going to drag our obstacle into there. And that's all we need here. Obstacle is all set. It's really, again, just a simple box with a collider so that our player can collide with it. And so we're going to, oops, delete that from our scene. Now the other thing I do want to do is when our player reaches this goal, we want to make sure that it knows that it's reached it and it knows it's the player that's reaching it. And there's a couple ways you can do that. You can do like a check when the collision happens or the trigger enter happens and see if it's the player object, but I'm just going to do this through Unity's physics system instead of using layers to see and make sure that only the player can trigger the goal. And now in order to do that, we need 2 new layers. We need a player layer and a goal layer. So I'm going to go player, add layer, and I'm going to add these 2 here. We're going to say player and goal down here into our custom layers. So now I can assign the player to the player and the goal to the goal. And then we're going to go edit project settings physics. And down here we have the setup for this. So what I'm just going to do is double check that the goal here isn't going to interact with anything except for the player. Now the player will still interact with all of the other things because we don't want the player to fall through the world or anything like that, but only the the goal will only notice if the player enters it. This would be useful if we had like an enemy character walking around, and if it walked through the goal, we wouldn't want to win the level because of that. I'm going to quickly save our scene here. I'm just going to call this level. And I'm just going to save that into the root right now. I think that's okay for our purposes. And with that, we can now start creating our scripts. I can reactivate the mesh renderer here again so we can see the ground. So we're going to create a folder, call it scripts, and we'll add 3 scripts to this. We're going to add a C# script called player, a C# script called goal, and a C# script called level manager. Now our player and our goal are going to be pretty simple. Start with the player. Let MonoDevelop load up here. I'm going to zoom in a little bit so you can see what I'm doing. First thing we're going to do is we're going to require component on the player. And so we're going to require component type of character controller, just so that we know for sure that we have one on this. Because then we're going to need a reference to that character controller. So I'm going to say character controller CC, and then in the awake method, so first thing when our scene starts, we're going to get set CC equal to get component character controller. Now, really all that this player script is in charge of is taking in our keyboard inputs and making the character move around the scene. And so the other thing we want here is a speed value. So we're going to say public float speed. We'll set that equal to like 3 for now. That's fine. And then I'm going to have 2 more floats here, one called xmove and one called zmove. And these are going to be, I'm not going to make these public because all these are going to be used by is the update function to keep track of movement. So what we're going to do here is we're going to say xmove equals input.getAxis raw. I'm going to get the horizontal axis. And then zmove is going to be equal to input.getAxis raw vertical. And then if either the xmove does not equal 0, or zmove does not equal 0, as long as we have some kind of motion. If both are 0, we don't need to move anything because we're not obviously pressing any buttons. But if either of these is being pressed, or both are being pressed, then what we're going to do is we're going to call on our character controller and tell it to do a simple move, which will take in a vector 3 for us. We're going to do a new vector 3 called xmove 0 zmove. We're going to normalize it, so we're going to say dot normalized, which basically that just means that if we happen to be moving both on x and z at the same time, it's going to reduce that to just 1 unit of movement for us, and then multiply all that by speed. And so that actually gives us our player motion controls. So we can apply this to our player, add component player, save that, and we should actually see now that we can move our character around. And we can. This isn't a great view for our scene, so let's actually solve that really quickly here. I'm going to put this at about 0, the camera here, main camera at 0, 6, and -9. And then we're just going to rotate on the x-axis by 40 degrees. And that gives us a little bit more of a bird's eye type view. Next thing we can do is work on our goal. I'm going to add that goal component right now before I forget to do so. And then we can jump into MonoDevelop and set up our goal. Our goal is really just going to have a couple of things here. We're going to have a void on trigger enter, which will take collider C. We're not actually going to use that, but it is part of the structure of this method. And all we're going to check here is we're going to do in here is say announce that goal has been reached. Now, how do we do that? Really what we're trying to do is we're trying to tell that level manager, hey, goal's been reached, do what you need to do to end the level. However, there might be other things that want to listen, and we don't really have a way of directly talking to the level manager right now. We could certainly, create a variable up here, call it, public level manager, and assign it. But instead, what we're going to do is we're going to use events, and this is going to be really important, especially for our level manager, because this is how we're going to be communicating into and out of the game. So we're going to create a delegate void, and we're going to call this goal reached handler, and it's not going to take any parameters in it. So I'll make this public just to be safe. And then I'm going to have a public static event called on goal reached. And so public static event, goal reached handler. Have to tell it what type of delegate to use. On goal reached. So this is now something that we can call, and we can say down here, when the player enters, call this, and anything that's listening to it will know that the goal has been reached. So we'll say if on goal reached does not equal null, meaning that something is listening, then we'll call that method or that event. And that's really all that this goal needs to do. Like I say, because we're using the layers in Unity, we don't have to worry about checking to make sure that it's the player, because only the player can actually interact with the goal. So we can save that. That has been added to our goal, so that's all set there. Last thing we need to do is set up our level manager. I'm going to add this to the level. And this is obviously going to be the most involved part of this, because this is really controlling how our game works and how it sets itself up and all that. And I'm going to delete all this in here for now. We're going to have a few things here. We're going to have some objects. We're going to have some level data. And we're going to have a couple of events here as well. So the first thing to do for the objects, we're going to have a public player called player, a public goal called goal, and our public transform called obstacle folder, as well as a public transform, which is our obstacle prefab. We can jump back to Unity, assign all of those really quickly. So player goes into the player, goal goes to the goal, obstacle folder, and then we'll take our obstacle prefab from the assets folder and drag it into there. So those are all set now. Now our level data, we really need three things. We need to place our player somewhere, we need to place our goal somewhere, and then we need to populate any obstacles that we have. So we're going to have a public vector3, which is our player position. We'll have a public vector3 goal position. And then an array of vector3s called obstacle positions. And that's for how, because we can put in however many obstacles we want. Lastly, I'm going to put in these events, and these events are going to be for when the level starts and ends, and they're going to make it possible for us to tell the level manager what to do or to listen to the level manager from outside of this kind of game structure. So we're going to have a public delegate void, and we're going to call this level start handler. And that's not going to take any parameters right now. And then we'll have a public static event level start handler, and we'll call that on level start. Likewise, we're going to have a public delegate void level end handler. And this one is I'm going to have this pass in a bool called level completed, so that say we are just quitting out of the game, we can say level end and false. We didn't actually finish the level. However, if we reach the goal, we'll call this level end event, but we can say, hey, true, we did finish this level. Increment the level access that this player has. So public static event level end handler on level end. So here we have, like I say, the objects, the data about the level, and then these events that we can use to kind of queue up and say, hey, you should set up the level right now. And in fact, that's the next thing that we're going to need to do, is be able to actually set up this level. And we need two things for this. The first thing we're going to need is a void method called clear obstacles. And this is just so that if we, say, start a new level and there's already a level that's been set up, we don't want, extra obstacles being added to the scene. We want to clear out the old ones and then put in some new ones. So for this, we're just going to simply say for each transform child in the obstacle folder, then we can destroy child.gameObject. And that's all that needs to do. So just we'll iterate through this folder and destroy anything in it. With that, we can actually create the scene to set up the method to set up the level. And this, the first thing we'll do is call that clear obstacles method. And then what we can do is we can position the player where the player's position should be. So we'll say player.transform.position equals, I'm going to do a new vector 3 here, and the reason I'm doing this, you'll see now, is I'm going to do that player position data we have .x. We're actually going to use the player transform's current position.y, and the reason for that is remember that we had that specifically set up so that it's standing right on the ground and it's not half buried in the level. And if we by any chance forgot in our data to put that exact number back in there again, the 0.75 I think it was, we don't want to suddenly be half into the ground or up in the air or something. So that just makes sure that we're always standing directly on the ground. And then player position dot z will take that. So it's really just the x and the z positioning that we're taking and using from the level data. Same thing we'll do for the goal. Goal.transform.position equals, and I'm just going to copy and paste this, save some time, and we can simply change this to goal position, goal, and goal position. Lastly, we're going to do a for loop, and this is going to be for I works, and then we're going to say for I is less than obstacle positions dot length, so it'll iterate through that entire array. Then we're going to say transform new obstacle equals instantiate obstacle prefab as transform. Now, we could, next thing we're going to do here is we're going to do the obstacle positions, the new obstacles position. We could do this a couple of different ways, but I'm going to just do it this way. I think it's the easiest. Equals new vector 3. And again, here we're going to do the same basic idea. We're going to say obstacle positions I, get the x value. Then we're going to actually take our obstacle prefab dot position dot y, the same way that we're going to inherit from sort of the basic the predetermined height that we want. And then for z, we'll do obstacle positions I dot z. Lastly, we need to assign the parent to be the obstacle folder so that when we clear obstacles in the future, it's in there to be destroyed. So we'll say new obstacle dot parent equals the obstacle folder. So with all of this information in here now, we are able to build our level, but we don't have a way to tell the level manager to build the level. A lot of times what we'll do, especially when we're first creating a game, is we'd say something like void start, and then just tell this to set up the level. And that works fine, and we can certainly do that. We can actually jump back here. I can go to our level. We see we've got all these here, so we can say players at -3, -3. Goal positions at 3 and 3, and we'll put a couple of obstacles in here at something like 1, -1, -1, 1. So we've got some data here, we can hit play, and now we're starting the level, and so we build the level and position it wherever we want it. That works, but the problem is that doing that, we're not really building this as a program, we're just building it as this bit of code that runs when we hit the play button in the inspector. What we really want is a way to be able to talk to this level manager from some other place, whether that's from a main menu, whether that's from some sort of online lobby, something that can say, hey, level manager, set up the level now. And there's a couple of ways to do this. The one that kind of sprung to mind for me at first was, I can make this into a singleton. We can make a static reference. We can say static level manager ins, make it public, and then just make sure it's a singleton so there's only the right thing is always the instance, and be able to refer to this instance and tell it to set up the level. And that works okay, but there's a few kind of shortcomings of that. You can only ever really have one level manager, which maybe you have a multiplayer game where you've got multiple levels next to each other, or you're trying to queue up a future level that you can just kind of teleport your camera to later, some stuff like that. So what I thought of to do instead is kind of use this event system and this static system to say, well, what if there was a static call that you could make from anywhere? Instead of calling on the static instance reference, what if there was just a method that would call this on level start? You cannot actually call, unfortunately, this event from, I couldn't call this from goal, or in particular, I couldn't call on level end from goal. I can't say on goal reached, and then say level manager dot on level end. That doesn't actually work. But what I can do is create a public static method called start level. And what this will do is this will say if on level start does not equal null, then call on level start. And so now we're able to call from outside of this class, call this, which will then set off this event. And what we can actually do is assign setup level to this event, so that now when we call this static start level method, which we can call from anywhere, we will make sure that each instance of the level in the game will set up its own level. So what we can do is we can say void awake on level start plus equals setup level. So let's kind of see this in action. I'm going to create an empty game object in our world. I'm going to call this outsider object. So this is obviously this object that exists outside of the whole game setup here. It's this thing, it could be a menu, it could be anything else we need it to be, that is going to talk now to our level. And I'm going to create this outside of the scripts folder because this is really just kind of a demo thing. And I'm just going to call this outsider script. I'll add that to the outsider object. And now when I open this up in MonoDevelop, what I can do is on start here, I can say level manager dot start level. Like I say, I don't need any kind of reference. I don't need to have a reference that I'm, dragging this onto here or into a variable. I don't even have actually a, singleton or any sort of instance of this. I'm really just calling a static method that is in this type. It's, in this class, sort of in the overarching ether, and I can just say, hey, any level managers out there, start your levels, which will call this, and because they have assigned themselves in the awake function, they will know to do that. Now, the only kind of, I'll call it a downside to this, is that you really want to only ever call this in the start method or later. You don't want to call it in the awake method because then you can't guarantee that everything is assigned itself before calling this. But for 99% of use cases, that should be fine. You probably won't be calling this until everything is initialized anyway, so this is a good time to do it. So now what we can do is we can hit play, and this outsider object, instead of using the awake method of the level, the outsider object will be telling our level to set itself up. So we'll hit play, and sure enough, everything is set up because of that outsider object. If I disable this outsider object, we'll see that instead nothing happens. So we are now able, officially, we're hooked up so that this outsider object can tell the level what to do. Likewise, we can set it up so that it will listen for things as well. What we can do is say something like, remember we have this onLevelEnd event, and so we can say something like void announce game over. And we'll give that a bool called completed. And we'll say if completed debug.log level completed else debug.log level over. Now, what we can do is, in the same start function, we can assign to our level manager dot onLevelEnd event, we can assign announce game over. The only problem is that right now we don't have anything that's ever actually calling onLevelEnd, so we can create a quick thing down here called void end level, and it will simply say if onLevelEnd does not equal null, then we will call onLevelEnd, and we'll just say that it's true for now. Now, once again, here we don't actually have anything calling this yet, but what we can do, remember that we have in our goal, we have this onGoalReached method, or event rather, so we can say to our level manager, hey, goal.onGoalReached, add to it that endLevel method. So now what happens is when we reach our goal, onGoalReached gets announced, level method is listening for it and says, oh, I should make level end happen, or end level happen, which announces on level end, which our outsider script, now we're outside of the game loop, we're in whatever, external UI object or whatever we need, knows that it can announce that the game is over. So let's go back here now and hit play. And we should see now that we're able to walk our character around, level knew to start itself because of the outsider object, and then when we enter this goal, sure enough it announces, and I can minimize this, we can see in the console, it announces that the level was completed. In fact, we can do this multiple times right now, I think. Yep, because we don't actually have it clearing out from there. But that's something we'll get into in future videos, because that's going to be something outside of our game loop of actually closing out a level, being able to load a new level, or successive levels, or restarting levels, stuff like that, as well as all the other cool stuff that we're going to be able to do now that we have this fairly simple featured game, but one that's able to communicate into and outside of itself, and we can start creating all the other features that will turn this kind of simple game mechanic into a fully fledged program. So thanks for watching, and I'll see you next time.